everybody and welcome to Primary 6A's YouTube channel. I hope everyone's doing really well and you're getting on okay. Obviously this is very different to what we're used to, so it will take just a little bit of getting used to, but I'm sure over time we will get there. So as always, if there are any questions that are for me, then you can contact me via Teams, and that is the best way to contact me. Also remember to share any finished work with me also on Teams. You can do that via the class notes section, and if you do upload work there, make sure you let me know by posting on the feed that you have uploaded something there for me to go and look at. If there are any problems with that, again, just pop a message and I am always here to help the best I can. So for this week's learning, we are going to be covering videos on 2D shape, including triangles and circles, and also for grammar, we are going to be looking at homophones. The next clip will give you more details about the learning taking place this week. In today's video, we're going to be talking about different types of triangles. And our first triangle we're going to introduce to you today is our equilateral triangle. Sometimes pupils refer to this as equilateral triangles because this triangle is special for its ability to have equal edges, so all edges are the same length, and equal angles. So sometimes pupils might remember the word equal and might refer to this triangle in that way, but it is pronounced equilateral triangle. The dashes in the line here, which you might see in some images, indicate that all edges are the same length. So for example, if this side was 6 centimeters long, the other two sides would also be 6 centimeters long. However, in an equilateral triangle, they could be any length. The only rule they have to follow is that all edges are the same. So if it was 30 centimeters, 30 centimeters, 30 centimeters, 2 centimeters, 2 centimeters, 2 centimeters, and so on. Also, whilst looking at triangles, pupils should be aware that all angles in any triangle add up to 180 degrees. So in this case, because all the angles are equal, we divide 180 by 3 angles, which is 60 degrees. So pupils should just remember that angles on an equilateral triangle are always 60 degrees because they each 60 add 60 add 60 add up to 180. The type of triangle today is an isosceles triangle. An isosceles triangle can look probably one of these two different ways depending on the length of the bottom of the triangle. However, isosceles triangles are special because they have two sides that are the same length, which again is shown using these dashes, that these two are the same length. However, this one only has one dash, which I have done in a different colour, because it is not the same length. And the same here, these two are the same length, this one is not. So for example, say these sides were 8 centimeters, this one would be 8.2, but this one could be 3 centimeters long. And similar for this one, I won't write it down, but this one could be 10, this one could be 10, but this is maybe 13, say. The same goes for the angles. So last we talked about equilateral triangles where all the angles were the same. However, in an isosceles triangle, one angle is different from the other two. The bottom two, they look the same just by looking at them, but they will also equal the same. So for example, if you're given a question where you're asked to calculate one of the angles, bearing in mind that all triangles, their inside angles add up to 180 degrees, the same as the last one. So for example, if you are told that this angle measures 20 degrees, then taking that away, that means we have 160 degrees left to share between these two. So we would just divide it, so that's this one would be 80 and this one would be 80. Our third type of triangle is our scalene triangles. Now these are unique as all of their sides are completely different lengths. I actually found them quite tricky to sketch, but I've shown in my markings here that this one does not match any of the sides and so on. They all have different measurements. So for example, we could say that this side is 3 centimeters long, this one is 5 centimeters, and this one will maybe say is 4 centimeters long, just for an estimate of how a scalene triangle may look. Alongside this, the angles would also therefore be different. So for example, in this one, we'll say this maybe is 30 degrees, this one maybe 70 degrees, which would mean this one would be 80 degrees. And similarly, all angles should add up to 180 inside a triangle, as we've said. So you could, if you were given two measurements, so like we did in the last example, 30 degrees and 70 degrees, then you would add them up, so that makes 100. So how much have you got left? That must be the last angle, so that one is 80 degrees. Our final type of quite special triangles is our right angle triangles. And the only property a right angle triangle needs to have is one right angle. However, why they are quite special is because some other types of the triangles we've covered today can also be right angled triangles. So as I've shown you in this example over here, an isosceles right angled triangle could be one that has two sides the same length, and one that is not the same length, so as long as it has a right angled. Or over here, a scalene right angled triangle, all different lengths of sides, all the angles would be different lengths, but it does have a right angled. You cannot, quite a tricky question to maybe ask people is why can you not get a right angled equilateral triangle? And the answer to that is that your equilateral triangles need to have 60 degrees at each angle, and a right angle is 90 degrees. So you do not get equilateral right angle triangles, but you do get isosceles and scalene ones. I hope that was informative. As always, if not, just give me a message, preferably on Teams. Thank you for watching and happy learning. Bye!